Okay, hello, honors. This is chapter 4, part 3. Today we're going to talk about Newton's third law. We're going to talk about Newton's third law. But first, let's review. Newton's first law was the law of inertia. Newton's first law is the one that says objects do not want to accelerate. Objects do not want to accelerate. The way we phrase it is, objects at rest tend to stay at rest. Objects in motion want to stay in motion at constant velocity. Accelerating is not our natural state. Newton's second law states that if you want something to accelerate, you have to force it. In other words, Newton's second law states that net force equals ma. There we have it. Before I move on to Newton's third law, I just want to make a quick comment about the second law here. Notice that the force here and the acceleration here have to be in the same direction. This positive and this positive means that the force and the acceleration have to be in the same direction. If the net force is positive, then necessarily the acceleration also has to be positive. Positive, positive. So net force and acceleration have to be in the same direction. Just as equally, we could make these both negative, of course. The net force could be negative, which would mean the acceleration would have to be negative. So either way works, but it's important to remember that the net force and the acceleration that results will be in the same direction. Okay, time for Newton's third law. Newton's third law. Newton's third law says for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. In other words, if you push me, I'll push you back. If you push me, I will push you back. Mathematically, we would say the force from one thing is going to be equal and opposite to the reaction force. For every action, there is an equal and opposite reaction. If I push on the wall with a positive force, the wall will push back with a negative force. If I push the wall to the right, the wall pushes back to the left. Okay? So, what will this look like for us? So, let's do a little example of how we can think about this. Imagine, I just said wall and pushing, so I'm just going to actually go for it with the wall and pushing. So there's me, put a beard on me, and got my baseball cap. There we go. Alright, let's just say, and this is a wall. There's the wall. Let's just say that I apply a force that direction. So there's a force, I'll just put subscript me, meaning that it's me applying that force. So I push on the wall, and does the wall move? Well, I'm not that mighty, so I would suspect that the wall, when I push on it, will not move. But if I lean right in there and I push really hard on that wall, what's going to happen is I am going to move that way, right? You've heard of a push-up or a push-off. Well, if I push on the wall, I'm going to move that way. Now let's think about it for a second. My initial velocity was 0. I'm just standing there. I push on the wall and suddenly I have some velocity in that direction, right? I push on the wall that way, suddenly I have a velocity this way. So my initial velocity is 0, my final velocity, I don't know the number, but my final velocity is going to be some positive velocity. So my velocity has changed. I have accelerated. Again, I don't know the number for the acceleration, but if my velocities are positive and I clearly sped up, then speeding up means acceleration and velocities are the same direction. Positive velocities means my acceleration is positive. My acceleration has to be that way. Well, this causes a problem for Newton's law because if you remember, Newton's law states net force equals ma. And they have to be in the same direction. This is positive, or both negative. Here's the problem. This force is in the negative direction, right? We're saying that way is positive, so that way is negative. So this force of me pushing on the wall is negative. The acceleration that results is positive. So Newton's equation says that this force of me pushing on the wall it absolutely cannot be the force that causes me to accelerate away from the wall. That is where Newton's third law comes in. Newton's third law says that for every action there's an equal and opposite reaction. So if I push on the wall in the negative direction, Newton's third law says the wall will push back in the positive direction with an equal force. So just to put a number on it, if I push with negative 10 newtons, the wall would have to push with a positive 10 newtons. For every action, there's an equal and opposite reaction, okay? All right, so what does that mean? That means we have verified Newton's third law. I push on the wall, I accelerate that way. It's actually the wall that is pushing me away, not me pushing me away. Now, before we get carried away about the wall having its own identity and its own personality and making choices about who to push and who not to push or any silliness, we have to understand that, of course, the reason the wall pushed me was because I pushed the wall. So the wall's reacting. And the wall's not just going to, out of nowhere, shove me away. It's reacting to me pushing. So I am involved in this somehow. But technically speaking, it is the wall that applies the force that causes me to accelerate away. Well, I hope that's a little bit clear, and I hope that gives you some idea about Newton's third law. In class, we're going to do an experiment. We'll do a little problem where we're going to drop a tennis ball and measure how fast the Earth accelerates up to meet it. That's right, the entire Earth. Well, see you in a minute.